Quebec's subsoil is rich in minerals. After performing 20,000 kilometers square of aerial surveys, we discovered a world-class graphite ore deposit in Saint-Michel-des-Seines. The Tony Block holds a probable reserve of 59.8 million tons of ore, with a graphite content of 4.35%. Since the graphite is in a near-surface deposit, the site will be developed as an open-pit mine. Extracting the graphite involves excavating the deposit and then processing the ore to produce a graphite concentrate with 97% purity. The overburden, or surface soil layer, is stripped and then stockpiled to be used in the future progressive reclamation cover. Waste rock consists of excavated rocks for mining operations that do not contain usable graphite. These rocks range in size from 0 to 60 centimeters. Tailings are the rejected, crushed, and finely ground rocks resulting from ore treatment after the graphite has been isolated at the concentrator. It is essential that we responsibly and properly manage these materials to protect the environment. When we excavate a deposit, we change the chemical and physical conditions of the host rocks. In addition to graphite and other minerals, the host rocks naturally contain sulfur, a common chemical element that is mainly found in the form of yellow crystals. Sulfur oxidizes when it comes into contact with oxygen in the air and water. Prevention of acid drainage requires that sulfur be isolated from atmospheric oxygen. We designed an innovative and sustainable way to manage the tailings to prevent acid mine drainage due to sulfur oxidation and to reduce the project's environmental footprint. First, we use a desulfurization process to separate non-acid generating tailings, which have a very low percentage in sulfur, from potentially acid generating tailings. After, the tailings are filtered to reduce their water content so that they can be trucked and placed in a stable stockpile that does not require any dam. This is the recognized and preferred method for managing the tailings of new mining projects around the world. To limit sulfur oxidization in the tailings and waste rock, we decided to implement a co-disposal approach. This method lets us manage all tailings and waste rock together in the same storage facility area to leverage the benefits of each material's properties. Waste rock is used to create cells, in which potentially acid-generating PAG tailings are compacted into a layer to increase water saturation. Next, the non-acid generating NAG tailings are added to the cell. They are then compacted and placed over potentially acid-generating tailings and waste rock in each cell to limit oxygen entry. This system therefore prevents sulfur oxidization. The co-disposal stockpile will be covered during the mine's years of operation for the final closure, that is, progressive reclamation. This multi-layer cover is made of material from the mine site, such as non-acid generating tailings and overburden. This layer will be vegetated. This type of cover is a proven method in mine reclamation. The progressive reclamation will be incorporated into operations to ensure a safer closure strategy. Also, to reduce the project's footprint and effectively manage the site over the long term, the pit will gradually be backfilled with waste rock and tailings starting in year 5, once there is enough space to do so safely.